In case the characteristics impedance of a transmission line is equal to the load impedance, all the energy sent will be absorbed by the load. In a transmission line of negligible resistance, the surge impedance will be root over L by C. Characteristics impedance of an overheaded transmission line is usually in the range of 400 to 500 ohm. Surge impedance of transmission line is independent of its length. The critical value of surge impedance of a long transmission line is 400 ohm. When the load on a transmission line is equal to the surge impedance loading, the receiving end voltage is equal to the sending end voltage. The propagation constant of a transmission line is given as j omega root over LC. Use of additional shunt capacitor can be made for increasing the capability of the line as it reduces the surge impedance Z0. To increase the transmission capacity of a high voltage long line, the series reactance can be reduced. Series capacitors is used in a transmission line to compensate the voltage drop. For a distortionless transmission line, RC equal to GL, where G is the shunt conductance between two conductors. Power dispatch through a line can be increased by installing series capacitor. The power transmitted will be maximum when sending end voltage is more. The capacity of a transmission line can be increased by reducing the line inductance. For constant voltage transmission, the voltage drop along the line is maintained constant by installing synchronous phase modifier at the receiving end. Constant voltage transmissions have the drawback of increase of short circuit current of the systems, lower reserves of line in case of line trouble, increased risks of interruption of supply due to falling of synchronous motor out of synchronisms, all of the above. Constant voltage transmissions have the drawback of increased risks of interruption of supply. Constant voltage transmission have the advantages of availability of steady voltage at all loads at the receiving end, possibility of better protection for the line due to the possible use of higher terminal reactance, possibility of carrying increased power for a given conductor size in case of long distance heavy power transmission, all of the above. Constant voltage transmission have the advantages of improvement of power factor at the time of moderate and heavy loads. A synchronous phase modifier as compared to synchronous motors of the same rating has smaller shaft diameters and higher speed. Phase modifier is normally installed in case of long line. Which of the following statement is not true? Synchronous phase advancers are installed at sending end. Overexcited synchronous phase modifier draw a leading current. Capacitors are used in power system to improve the supply power factor, improve the voltage regulation, change the load characteristics, all of the above. Series capacitors on transmission line are a little used when the required reactive volt amperes are small. Cable are usually used for voltage up to 33 kV. Nowadays, the 220, 132 kV cable are being used. Power transmissions by cable is generally adopted for line length less than 50 kilometers. Normally, expected life of cable is around 15 years. Conduit pipe is generally employed for protections of unsheathed cable. The sheaths are used in cable to prevent the ingress of moisture. The material commonly used for sheath of underground cable is lead. The bending of a cable consists of jute strands, Hessian tape, paper tape compound with a fibrous material, or any of the above. The material used for armoring of an underground cable is galvanized steel wire or steel tape, A or B. Which of the following protects the underground cable against mechanical injury? Armoring. Metallic sheathing is provided on underground cable to reduce thermal resistance, reduce corona effect, control the electrostatic voltage stress, all of the above. Metallic sheathing provided on cable is usually of thickness 3 to 5 mm. The effect of bonding the cable is to increase the effective resistance but reduce the inductance. Copper used as conductor in a cable is annealed. The size of conductor used in power cable depends on current to be carried. The thickness of insulation layer provided on the conductor in cable depends upon the operating voltage. The insulating material used for cable should have all of the following except higher water absorptions. The insulating material most commonly used for power cables is paper. The insulating material commonly used in cable is PVC, empire tape, paper, rubber, any of the above. Empire tape is varnished cambric. The relative permittivity of rubber is between 2 and 3. Dielectric strength of rubber is about 30 kV per mm. Paper as a insulating material has the main drawback, that is hygroscopic. The maximum safe temperatures of paper insulated cable is about 95 degrees Celsius. In paper insulated cable, the conductor's cross section is usually limited to 600 square meter. The dielectric strength of impregnated paper is about 30 kV per mm. Paper used as an insulating material is usually treated with oily compound because its get electrostatically charged at high voltage. Single core cable are usually not provided with steel armoring. Single core cable are usually not provided with armoring in order to avoid excessive loss in armoring. Single core cable should have armor made of non-magnetic but conducting material. Multi-core cable usually use over-shaded conductors and sector-shaded conductors, either A or B. In a 3-phase 4-wire cable, the cross-sectional area of neutral conductor is equal to the area of the phase conductor. Low tension cable and high tension cable can be used respectively for voltage below 1 kV and 11 kV. The belted type constructions is not suitable for cable used for voltage exceeding 22 kV because of development of both radial and tangential traces, formations of vacuous space and voids on loading and unloading owing to non-homogeneity of dielectrics in belted construction, local caused by power loss at center filling owing to leakage current produced by tangential traces along the impregnated paper insulation resulting in breakdown at any time, all of the above. SL type cable over H type cable have the advantages of possibility of bending of cable owing to no overall lead sheath, less tendency for oil drainage on hilly routes owing to eliminations of filter space containing compound. Screened type cable over belted type cable have the advantages of reduced possibility of core-to-core faults, uniform radial electric traces in all sections of the dielectrics, no possibilities of formations of void within the dielectrics, and increase the current carrying capacity. All of the above. Solid type cables are not considered suitable for operating voltage exceeding 66 kV because there is a danger of breakdown of insulations because of formations of void in the layer of dielectrics. Cable generally used beyond the 66 kV. Oil field cable. Oil field cables have the advantages of no ionization, oxidation and formation of void, possibilities of increased temperature range in service, more maximum permissible traces, all of the above. Oil field cable have the advantages of smaller overall size, perfect impregnations and easy detections of fault, all of the above. Oil field cable have the drawbacks of greater cost and complicated laying of cables and maintenance. The cable used for 132 kV are extra super voltage. Cables used for 220 kV lines are invariably compressed oil or compressed gas insulated. The insulation used in cable designs for use on 1000 kV is usually compressed SF6 gas. Sulfur hexafluoride cable is insulated by compressed gas. In compressed gas insulated cable, SF6 has the gas pressure in the range of 3 to 5 kg per centimeter square. VIR cable are usually used for 6.6 kV. Cable used in automobiles and arc welding sets are VIR cable. At bridge crossing and near railway track, ternary lead cables are used because they are low specific gravity. Internal pressure cable have the advantages of eliminations of external accessories, suitabilities of for vertical run without any fear of drainage with suitable design, marked improvement in the PF of the cable, dielectrics with the increased pressure, all of the above. The insulation resistance of the cable decreases with the increase in the length of the cable. With the rise in temperature, the insulation resistivity reduces exponentially. The insulation resistance of a cable of length 10 km is 1 megaohm. Its resistance for 50 km will be 0.2 megaohm. The leakage resistance of a 50 km long cable is 1 megaohm. For 100 km long cable, it will be none of the above. The power factor of an open-ended cable can be improved by increasing the insulation resistance. The capacitance of a cable increases linearly with the increase in the cable length. The capacitance of a cable depends upon the length of the cable, relative permittivity or dielectric used in the cable, ratio of sheath diameters to core diameters, all of the above. The charging current drawn by the cable lead the voltage by 90 degree. The dielectric traces in a cable is maximum at the lead sheath. In an underground cable, the dielectric traces is maximum at interface of sheath and the conductor. In underground cable, the electrostatic traces is maximum at conductor surface and minimum at sheath. In a cable of conductor diameter small d and overall diameter with dielectric material capital D, the maximum dielectric traces occur at the conductor surface and is proportional to 1 by d. In cable having homogeneous insulating material, the maximum traces is of 20 kV per mm. The dielectric traces of the insulating material should be 20 kV per mm. Surge impedance of cable is around 50 ohm. Surge impedance of a 50 miles long underground cable is 50 ohm. For 25 miles length it will be 50 ohm. The breakdown of insulation of a cable can be avoided economically by using insulation's layer of different dielectrics or intersheet A or B. In capacitance guarding of cable, the dielectrics used is composite. Capacitance guardings of cable means use of dielectrics of different permittivities. The intersheets in cables are used to provide proper trace distributions. The desired overall diameters of the conductors without increasing its cross-sectional area can be had by using aluminium core instead of copper, stranding the copper conductor around the hem centers and stranding the copper conductors over the lead tube. The capacitance between any two conductors of a 3-core cable with sheath earth is 3 micro-ohm. The capacitance per phase will be doubled, 6 microfarad. Aluminium conductors cable can be joined by compressions. The method used for jointing of copper conductor cable and aluminium conductor cable is transmit welding or soldering or compression. Soldering and compressions. The method used for laying of underground cable is drit laying, draw-in system, solid system, all of these. Direct laying method of laying underground cable has the drawback of high maintenance cost, localization of the fault difficult, possibilities of damage of cable sheath owing to undergoing chemical changes due to impurities present in the soil, risks of cable being damaged at the subsequent evacuations work carried out for expansions or repairing, all of the above. Draw-in system of laying underground cable have the drawback of higher cost, reduced current carrying capacities of the cable, requirement of much deeper and wider trenches, repairs, alterations or additional difficulties, all of the above.